Ну так что?
A Universidade Estatal de Moscou, ela é membro do Instituto de Psicologia da Academia de Educação da Rússia, ela é pesquisadora no campo de Psicologia do Ensino, e ela é autora de livros e vários resumos e materiais, recursos educativos digitais, voltados ao ensino de biologia. E, além disso, ela também desenvolve na Escola 67 projetos educacionais especializados, voltados para a área de biologia. A professora Vera Zaitseva, também professora da Escola 67, ela como é um currículo extenso, eu coloquei aqui para não esquecer. Ela é bióloga, ela é chefe do Departamento de Ciências Naturais da Escola 67, em Moscou. Ela é coautora de livros e materiais didáticos voltados aos professores de biologia do sistema ELKONIN-DAVYDOV. E, além disso, ela é uma pesquisadora que tem uma vasta publicação sobre o ensino de biologia. O professor Dmitry, que é também um professor da Escola 67, ele vai participar conosco agora da conferência, e ele é autor também de livros didáticos de biologia que são utilizados no sistema ELKONIN-DAVYDOV. Então, pensando aí naquele preâmbulo que o professor Libânio fez sobre a teoria, né? Aquelas provocações que o professor Davis nos fez no início da manhã. Na manhã, vamos aprofundar agora um pouco, né? E vamos pensar aí como que o ensino de biologia pode ser pensado e pode ser desenvolvido de forma concreta a partir da perspectiva do sistema numa lógica desenvolvimental, ok?
Can we begin? Hello, dear colleagues. Do you hear me? I am happy to see you at this conference. I often remember my visit to Guyana. No, it's. Are you hear me or not? Should we begin? Okay. Hello, dear colleagues. I am happy to see you at this conference. I often remember my visit to Guyana a few years ago and our warm interaction. I am very glad to listen to Professor Libanio today. My English is not brilliant, but I hope we will understand each other. It's my pleasure to introduce now my co-workers, biology teachers Vera and Dmitry. Our common presentation will focus on the basic principles of the ELKONIN-DAVYDOV educational system. The new biology course we have developed is based on those principles. Next slide, please. The main stages the main stages in this development of the education system in Russia are presented here. Initially, courses for primary school were created and the main theories were developed. Then we started to make courses for the secondary school. Next slide, please. We started developing the biology course about 25 years ago. There were several stages of development and testing. In the last trial, 35 schools took part in experiment. Here there are teachers, our teachers. Next slide, please. Why does not satisfy us in traditional biology teaching? Pupils do not assimilate important biological concepts well enough. Difficulties in the assimilation of biological key concepts by both school-age children and also students occur in many scientific studies. The results of these tests show why it is so. We explored the assimilation of the concept of photosynthesis, one of the key biological concepts. In the diagnostic test, students solved a three-part task. The first part was to reproduce the definition of photosynthesis. The second part required an understanding of what photosynthesis is. The third part was to solve the problem using an understanding of photosynthesis. And it was not obvious that it is necessary to use exactly this concept. The seventh graders has just studied photosynthesis. They did well in the first part of the task, about 72% of right answers, you see. You can see how much their understanding is lagging behind their memorization, only 15%. After 2 years of learning, only a small part of pupils had improved their understanding. Those who had just learned without understanding had forgotten everything they knew. Next slide, please. I would like to say that the first results of the piloting of the course have been very impressive, of our course. This slide shows the results from one teacher's classes. 3 classes were taught according to the traditional course. The 4th is the next graduating class. These children were taught by experimental course New Biology. You can see here their achievements in solving problems using biological concepts. And these achievements are much better. Next slide, please. No, it's no. No, next slide, please. Yeah. Oh, it's not. Так, что они показывают-то? Не ту презентацию. Они не ту презентацию. Okay. Now about the main principle of the ELKONIN-DAVYDOV system, which is based on Vygotsky's cultural historical theory. Main ideas of Vygotsky, ELKONIN, and Davydov about education are in very simple form on this slide. So, what have we changed in biology education to make students more interested, understanding biology, able to solve problems using biological concepts? We have radically changed the content of biology education. Next slide, please. What means to change the content? I will illustrate this idea with a simple example. There are 2 words in front of you. One is meaningless, unfamiliar. I think it is so either for Russian people or Brazilian people. The other word is clear for you. You have the concept of oxygen behind it. For students who have not yet studied biology and chemistry, both words are equally incomprehensible, meaningless. Next slide, please. If I show you a pot with a label with the first word written on it, you will have some idea of what the word means. This perception or empirical concept will become more definite if you see with your own eyes what's inside and taste the content of the pot. Please note that you cannot do this with the word oxygen. Children cannot see it directly, taste it. Therefore, the meaning of this word remains unclear to them if it is explained only in words. Next slide, please. Next, please. Oh, not before. One before. Previous, yes, this one. Слушай, куда они делись? Не знаю. But real understanding will come to you if you learn how to make this Chyavanprash and know why you need it. This understanding of the origins of things is a theoretical concept. So, next slide, please. No, next. Next. Yes, this one. So we see that verbal explanations are not enough to give a full scientific meaning of the word. The child must be given a practical means of distinguishing between air gases. By learning to distinguish between air gases in their own actions, pupils replicate key moments in the formation of the scientific concept of oxygen. This is what we did with all the biological content that children learn in secondary school. My example was rather abstract. Now Dmitry will show you an example from our course. Thank you. Now Dmitry, please. Next slide, and Dmitry will speak.
Hello, my name is Dmitry, and now we will trace the logic of development of the concept of respiration as an example of working with concepts in the course of new biology. We begin the course by looking at the term biology as the science of living things. Quite quickly, the children come to understand that living things cannot sustain themselves and remain alive without satisfying some basic needs. A list of these needs is compiled by the class. In order to separate resources and conditions, as well as to move on to the processes that occur inside a living being, the following scheme is constructed. Please, next slide of presentation. And the next one, maybe. This one. It already contains some interpretation of the concept of breathing, of respiration. This is some basic unscientific notion based on the sensory experience of children. It may be formulated approximately as respiration or breathing is the process of letting air in and letting it out. Next slide, please. Here you see the list of some first experiments of introductory module of our course. And I'm talking about the very beginning of it, even before all these experiments. Now I will try to describe briefly the logic that leads us to the fourth experiment, which we'll review more detail. So based on the diagram, the class understand that we don't know exactly whether the air changes between inhalation and exhalation. This needs to be figured out in order to figure out why respiration is necessary for life. The first question students must answer is how air can change at all. They quickly distinguish between qualitative and quantitative changes. They are then asked to formulate their own guesses as a text about how does air change during breathing. Next slide, please. You can see now an example of this task on the screen. The computer version of this task turns the written text into a scheme itself. Please, next slide. The scheme can look like this. The children working in their students' books should make this transformation independently. After that, all the hypotheses of the class are collected. Next slide, please. It's very important to stop at these points and practice in reading the diagrams. I usually insist in the class on having different students read all the schemes one by one, and then for each one we write down the number of people who think this exact way. This repeated translation of information from one modeling form to another and back again allows children to realize the essence of their assumptions and emphasizes the fact that they are exclusive, that one cannot be true with the other one as well. After next slide, please. After formulating hypotheses, the class moves on testing them. Usually children can formulate their own way to quantitatively test the air with a balloon. This experiment is quite simple and can always be performed live. When it turns out that air doesn't change in quantity during breathing, we go back to the hypothesis and mark half of them as incorrect. This is such a micro step in changing a concept. We don't need to be, it doesn't need to be articulated verbally, although it's important to go back to the assumptions so this change can be realized. Next slide, please. When testing qualitative changes, students are first asked to review Robert Hooke's experiment, the one where he invited the venerable academics of the Royal Society to breathe into a bag. Naturally, we don't conduct this experiment in class, but we nevertheless write down the result and conclusion of this experiment. So it turns out that the air varies in quality. It changes in quality. We go back to the hypothesis again and work with them. So only one correct remains, which leads us to a new change in the concept. So now breathing is a process of only qualitative change in air. However, the answer to the question why do we breathe remains unclear. Next slide, please. Students are usually quite quick to determine that in this case, quality is the composition of air and offer to test its change. However, they do not yet have the means to check it. After all, they do not yet know how to identify air gases and do not know the difference between them, although they usually have some vocabulary knowledge of composition. They knew some oxygen, some nitrogen, something like this. Then teacher offers them such tools in the form of qualitative reactions to oxygen and carbon dioxide. I mean experiments with combustion and lime water. And then offers to formulate the course of experiments to detect oxygen and carbon dioxide in atmospheric air. It's simple enough with oxygen, but with carbon dioxide there are some difficulties because there is little of it in the air. There are several ways, different ways to do this. One with increasing the surface, like pouring lime water into a dish, a petri dish. One with increasing the interaction time, and one with passing air through the lime water. Once the way with letting air through has been discovered, students can already formulate a way to compare inhaled and exhaled air in terms of carbon dioxide content. Next slide, please. Then we show the device, and students try to figure out how it works. It's important to understand, but not just memorize, because you can switch the tubes and get a different result. Of course, children do not quite understand the concept of pressure yet, but they can realize that it is easier to push air than water. To confirm that this is how the device works, we demonstrate the experiment with tap water. Now, first video part, please. So here children can see how does gases pass through each tube. Then next slide, please. After the demonstration, it is necessary, as in the previous experiments, to formulate all possible assumptions and expected results for each one. Then we can perform the experiment already with lime water in the test tubes. So next part of the video, please. No, not next slide, but next video. It can be performed even with one of pupils. After these experiments, we must make the conclusion from it. Here it becomes apparent to the students that the conclusion is just a confirmed hypothesis. But we need to be careful not to confuse the result, what they experience, and the conclusion, what they can understand based on the result. We don't do comparisons on oxygen and nitrogen in the classroom because they are quite complicated. Next slide, please. Students are not the previous one. Still the previous one. Students are then asked to work with charts and tables, again transferring information from one modeling form to another. And now next slide. The control stage in this part of changing the concept of respiration is the task of changing this black box scheme. When doing this task one more time, if student performs it as it is shown on picture, this means that his or her understanding of the process has been changed successfully. In addition, by doing this task, he or she can also quite consciously trace this change. Next slide, please. So here are some key points of this process. Again. And next slide, please. So in the future, the concept of respiration will develop further, gradually approaching more and more to its scientific meaning. So if anyone have some questions to my part, I can answer it now if there is possibility for this, because I'm in Romania now and I have very big time shift. Or we can move on and my colleagues will answer the questions later.
Что, Денис? Угу.
Okay. Okay, now I will leave. Thank you.
So, good afternoon, dear colleagues. I'm very happy to speak to you. It's a great honor to us that we were asked to participate in your conference. I often remember the visit of Brazilian colleagues to Moscow, to my school. I'm very grateful for this visit to Andrea, to Alcides, and to Renata. I warmly remember their presence at our lessons in primary school, in primary science course, and also in secondary school at our biology course. I'm going to prolong the presentation of our course named New Biology. And here you can see the key concepts, which are the skeleton of our course and the roadmap of the course. The succession of concepts is very important. We start with the concept of respiration and how respiration is connected with gas exchange, nutrition, excretion. Part of this way to the concept of respiration was told to you by Dmitry. The next step is the concept of the internal environment and the boundaries of the living being. So the concept of organism grows out of these two first steps. All this is done using animals as objects for experiments, as objects to refer to. Plants are different. They are autotrophic. And the next thing to do is to understand the concept of photosynthesis. Knowing all this, we are coming to the ecosystem concept and have to analyze the processes in the organism and ecosystem when conditions change. So the concept of feedback as the main principle of regulation arises. Now we pass to evolution and look at life at a long time distance. So students discover natural selection. As it is impossible to build this concept without a clear knowledge of heredity and its molecular basis, it has to proceed. So you see the succession of concepts to which our course is made. Next slide, please. The standard traditional way of teaching some scientific concept is to tell the student the definition of it and add some explanation and illustration. It is, to our opinion, a dead-end way. We need to organize learning in the manner that helps students to discover the concept themselves. A model is a means of retaining and developing a concept. Key concepts are constructed gradually, step by step. First, some object relation is highlighted. It is not a thing. It cannot be seen visually. It can only be thought about. Therefore, a special means of capturing is needed. A sign, for example, a word, or a symbol. This is how modeling begins. You have heard about it in Dmitri's part of our lecture when he showed you how students firstly model the process of breathing, knowing nothing about it, and choosing between the hypotheses. Each model develops, becomes more complex. Then it can be used as a means for solving different tasks. For each key concept, special suitable model forms are selected. It is very important to have different model forms to find a suitable, the best model form for each concept. And also to have several model forms for each concept, so students can pass from one model form to the other. Next slide, please. Here you can see the different ways of modeling. On the first photo, you see the modeling of body boundary of a living creature with threads. These threads represent different kinds of boundaries. Red thread represents the protective boundary, and the gray thread represents the exchange boundary. For example, the place for gas exchange. On the next photo, you see the simulation of oxygen and organic substances transport in the form of a simulation game. Children are transferring each other some pieces of sheet, or some sheets of paper, sorry, or some pieces of plastic representing oxygen and organic compounds, so they can use them in respiration. And out of this game, they find out the problem of circulation, that living beings need some medium to circulate in the body, and make their hypothesis about how it can be arranged, whether it will be cells or just liquid, how it can be moved, and so on. The next photo represents the modeling of connection of body functions in the form of a diagram. And you see just the students who are trying to improve what they've made already. Next slide, please. The first photo on this slide shows you simulating gas exchange in Amoeba on a magnetic board. Some magnets represent oxygen molecules, and other magnets represent carbon dioxide molecules, and so it works. The next photo, sorry, Let's wait for slide to return. Oh, okay. Next photo represents the modeling of the body boundary in the form of drawing a diagram. And the next slide, I'm sorry, but I think that you do not see the last photo. Can something be improved? Okay. Here you see the blackboard with the sheets of paper with some terms of anatomic structures and physiological processes. Sorry. And okay. Shall I start again about this slide?
Да.
Okay. So you see the different forms of modeling. First photo represents the modeling of gas exchange in amoeba on magnetic board. One type of magnets represent oxygen molecules, and the other colored magnets represent the carbon dioxide molecules. The middle photo shows students' work, just drawing on paper. It is also the modeling of boundary of the body of living being. And the last photo shows the modeling of feedback in physiological processes. So the different types of model building you had seen, and you can notice that it is the own activity of students. It is what they do with their hands, with their interaction, not individually, together. What happens? Sorry. Next slide, please. Here I have to explain the principle of how modeling is organized. Model building, development of a key concept, takes place in the classroom through sequentially solving a system of learning tasks, several of them. Learning task is not the task which is given just by the teacher. Teacher does not say to students, do this, this is the problem. The teacher helps the students to set the task and organizes the search for a solution so that every mental step the student takes is recorded in the model. Next slide, please. What happens to the model as the learning activity unfolds? This unfolding is represented here by the red ribbon, and learning tasks are represented by kind of red balls. So what happens to the model? It develops each next step in the modeling process when solving the next learning task. So the next task is becoming wider, is covering the wider field of problems. Children together build a model, a concept. Application of the model takes place in a different type of task. Often it is at the intersection of subject lines. The other subject line is represented here as a green ribbon. That second kind of task we call learning trial or try out task. I'm not sure that it is correctly translated into Portuguese. It is very different to translate it to any other language. But these are two different types of tasks. Next slide, please. A learning task involves, first, discovering of a contradiction, finding some knowledge gap. The second step is finding a way out of a contradiction, solving a problem, constructing a concept, building a model. The third step is specifying the method of action or concept on more individual objectives. For example, understanding of the principle of diffusion as the basis of gas exchange. First is produced using amoeba as an object, and then it is specified to other living beings, for unicellular living beings, and then to multicellular animals. And then when the other line, the other part of biology appears, we have to apply this principle to plants. If you return to the previous slide, I'll speak a little bit about it. Previous slide, please. For example, we developed the concept of respiration. This is the red ribbon, but we develop it according to animals, referring to animals. And then we try to start investigating plants. What about plants? Do they breathe the same as animals? It becomes a problem. And this is kind of learning tryout task. It involves discovering in your mind in a concept that is suitable for a new task, for a new problem. Next slide, please. Next slide, please. And the next one. Okay. Children develop an understanding of the selective permeability of the boundary of the living being, for the example of an amoeba. But this understanding is built not only and not so much in order to do it later on examples of an elephant, crocodile, and other living creatures. It becomes necessary, for example, in the design of an artificial kidney. And the model is taken there is an already rolled up form. So some more words about it. The illustration you see here shows the formation of idea of cell living boundary and diffusion process as the basis for gas exchange. From the point of view of children, firstly, they do not see, and nobody tells them, that this concept of diffusion, of selective permeability, and concept of body boundary is applicable to the problem of how to make an artificial kidney. But it turns out that not all the children in the class, but many of them can make a project of an artificial kidney, can discover the principle of its working. Nevertheless, it is not felt by them at the first moment that they can do it. That is a real learning trial, an application of knowledge they've already gained to the new problem, just another kind of problem, but it is successfully reached. Next slide, please. This mode of teaching and this mode of learning has some specific traits. First, students are working together. The steps of solving a learning task and thus making hypotheses, planning experiments, interpreting their results, making the conclusion, lead the class as the learning community to the next concept. The achieved new knowledge and understanding later is used individually to find an answer to a tried-out task. Next slide, please. The other side is that learning is active and interactive. Illustrative explanatory method is still widespread, but it has to give the way to an activity-based approach. Next slide, please. It is hard to teach in this way. As a rule, teachers plan their own activity, what to tell and what to demonstrate. But it is not good for our system. In our system, teacher has to plan a lesson in 3 steps. First step, what has to appear in students' minds in this lesson? Second step, what should students do to make this happen to them? The third step, what should a teacher do to get students to do just that? Next slide, please. As it's so difficult to change the style of teaching, we have produced resources for students and for teachers. My colleague, Denis Minkin, will tell you much more about our course and about the resources which we produced for students and also for teachers. Thank you for your kind attention. If you have some questions, we are ready to try to answer them. Поняла, что я отвечу?
То есть ты в другую сторону?
Нет. Канва была та же, но я говорила больше, чем у меня написано.
Да. Угу. Хорошо.
Сейчас я буду слушать и вам передавать. Third question.
Ты по-русски говори, если можешь.
Когда мы изучаем границу живого существа, используя материальную модель, представляем границу с помощью материальной модели. И это будет моделирование физических понятий или теоретических понятий. Если я правильно понял.
Моделирование всегда моделирование теоретических понятий.
Да, потому что он схватывает невидимое.
Так, нам как отвечать, Денис? Куда?
Если вы можете, нет, если вы можете говорить просто по-английски, вас слушаю.
Да, пожалуйста. Okay. We got a question about the type of modeling. If we are modeling the boundary of living being, is it the modeling of empiric concept or of theoretical concept? So our answer, we do not need to model empiric concepts. Empiric concepts arise from natural experience of every human. So if we are modeling during the educational process, it is always modeling of theoretical concept. We do not need to model empirical concept.
Спасибо. Сейчас попробуем ответить. Еще вопросы?
Угу.
Давай.
Сейчас на следующий. Английский. Может, на английском? Я сам не слышу.
Ну, что сделаешь? По крайней мере, это можно.
Вопрос в том, как вы проверяете, что они достигли понимания, а не просто там
Скажи, что ты им можешь показать позже какую-нибудь трехуровневую задачу. Сейчас.
как можно начнут ли они увидеть
Мгм.
We got two questions. One question is about the problem of being absent at the lessons due to some illnesses and so on. It is really a problem, a much more serious problem than in traditional way of teaching. But there are some ways to solve it. First, each of our teachers has a special time for additional consultations, additional time to meet the students who were absent. And individually or in small groups, the teacher answers their questions and helps them to fill the gap. This is the first way. The second way, we've got a support site with the materials which can help the student to fill the gap. The second question we got already is the question of the interested and not interested in biology students. You see, as a rule, students are not interested in the subject if they have only to memorize the information they do not understand clearly and do not feel they need it. Why is it so? Traditionally, it looks like this. Teacher comes to the classroom and announces, today we will study protozoans, or today we will study the heart structure and function. Why protozoans? Why heart anatomy and functions? Students do not feel the necessity of this. But if they, from the first lesson, produce their own questions, and the next step is surely the way to find the answers to these questions, it is quite different. I think that at the first part of the conference, Dennis told you about the first lesson of biology, when students feel the problem. Why do we breathe? What for? Why do we eat? What for? Why do we drink water? What for? It is so different, these three things. And the only answer they can give is to live, just to live. And all the students feel that the problems they aroused at that lesson and the problems which they do not have the good enough answer for are really their problems, and they are going to find the answer to them, the solutions of them. When we started to use the new biology program, and at my school it happened 12 years ago, the interest of students, their need of learning biology grew up substantially. Of course, There are always the students which are not interested in education at all. But even if they are not interested at all, the amount of such students is less when we use new biology program. Not sure. We are waiting for the next question. Ну, то что? Земля большая. Sorry, we're waiting for the next question, but there are some problems with connections.
Давай. Да.
Итак, я услышал вопрос. Сейчас я его спрашиваю, какая... Он спрашивает о мотивации учителей для перехода.
Окей.
Да. Только умный. Скажи, что только умный.
The question is, what is the teacher's motivation to change the program? It is the same as with the students. Answering the previous question, I did not emphasize one important point. Students at our lessons have to think, have to use their mind, their intellect, not only their memory. This is quite natural for a human being, and this is interesting and attractive for many children, not for all, but for many of them. Also, it is natural and attractive for teachers, not for all. And I'm sorry, not for too many of them, but those who feel that the traditional way of teaching, when you just transfer information to students and control how they assimilated it, is rather dull. You see, some people, especially children, think that teachers' job is very dull because every year they tell the same. Teachers know that it is not the same, but in traditional teaching, you change the way you give the information, but you are just giving it, transferring. You can illustrate it by videos, photos, drawing, make your schemes, and so on. But still it's transferring, and still it gradually turns teacher to the burning out process. The teachers of ELKONIN-DAVYDOV system never burn out, because every lesson, or nearly every lesson, especially the lessons with modeling, is a real quest for a teacher. You have to think every moment of the lesson. You have to appreciate, to control, to see what is going in the minds of children. Simultaneously, you have to think about your next word, about your next action, to lead the lesson in the proper way. And you have to organize students' thinking. It is very difficult, but very interesting. And the results, the students' understanding, makes you feel that all was not in vain. So that is the motivation. No teacher can be made to teach new biology or any other ELKONIN system curriculum, because it is not the variant just to follow instructions and do what you have to do. For example, the administration of school makes you to do this. It won't be a success if a teacher does not feel himself or herself that he needs this way of teaching. He won't be successful even if he tries to some circumstances. Is my answer clear enough? Maybe you'll ask some more.
Yes, yes.
Mhm.
Uh, Dear Professor Raquel, Lena asked me, not being sure of her English, to tell that she's very happy to hear from you and to hear your question, and very thankful for your kind attention to our lecture. I will try to answer partly to your question, but in one of next days, you'll see Полина Минкина and Anna Tavrovskaya, who will tell you about their experience of teaching just the students with very bad problems. The part of the answer I want to deliver is like this. The experience which is in need to make our concepts by modeling is quite natural for every human being. Every person eats something. There may be lack of food, bad food, but some food the person gets, otherwise it won't be alive. Breathing is our every minute experience. Movement, watching plants and animals. Some plants and animals are known to everybody. Just a moment.
Что дети с проблемами, с такими, которые, например, плохо говорят или что-то, для них более естественно моделировать.
Okay. Children with problems, for example, with not well-developed speaking abilities due to their educating in some foreign language for them. Children with some other mental problems. Modeling is much more natural way of learning for them than just reading texts and trying to make written or verbal oral communication. We had a student many years ago who was kind of autistic to a rather large extent, and he was never interested in what was going on during the lessons. But once, when there was modeling of transportation of organic compounds and gases in the body, he took the active part in that game and went to the blackboard and made some conclusions of it. Я правильно сказала? Yeah. So, the other information about our experience in this field, you'll get from Tavrovskaya and Minkina, because it is their experience. They were teaching in the schools. There were a lot of children with such problems. We are waiting for the new question. No, Okay. Andrea asked about the preparing teachers to work in ELKONIN-DAVYDOV system. You see, ELKONIN-DAVYDOV system has a long and uneasy history. Nowadays, our authorities are going to stop it in Russia. Because to the reason that they need mainly unthinking patriots than really thinking people. But we still have some courses for magistrants in Pedagogical University in Moscow. This field is headed by Vladimir Grovsky. And also we have some courses for teachers in University of Maro. I think some colleagues know about it. Some private schools which are not so depending on authorities and what they say, I think we'll use ELKONIN-DAVYDOV system in the future. But not many schools now are using new biology due to bureaucratic problems, due to difficulties which are dealt with it. I think that Denis Minkin can tell you more about it. We are waiting for the new questions.
Так,
We received a very difficult question, and now we are
пытаемся его понять.
trying to understand it and to answer about what is the problem and how it deals with necessity and subjective or
Ну,
objective.
попробуй привести пример с границей, да, что она одновременно пропускает, и что вот так возникает противоречие, что детей загоняют в ситуацию противоречия.
I'll answer with an example, and I hope that the answer will be just to the question, but I'm not sure. I try to tell you about the problem of body boundary. When students get the knowledge of molecules and their trait that molecules are always moving, of course we know that they are moving only if the temperature is higher than absolute zero, but it doesn't matter because it's not biological field. They try to make the model of boundary. As they know that boundary has to protect the living being's body, it is not supposed to be permeable for molecules. They draw it as some line, but then other students tell them there are no lines. If we draw the part of boundary in the size of molecules, the boundary should also consist of molecules.
И она должна пропускать в себя,
And
потому что внутрь должно что-то попадать.
Some molecules have to come inside, and some molecules have to come outside.
Возникает противоречие.
Also, boundary has to exist, and has to exist as this boundary protects internal environment from external environment, and they do not mix. But if it is so, how can some molecules come inside and some molecules come outside? And the third thing, if the boundary itself consists of molecules and molecules are moving always, so the boundary will be ruined and the external and the internal environments will mix. So, as one of our students, being 12 years of age, said at the lesson, it's a paradox. The boundary exists and does not exist. It has to exist, and it has to not to exist. This is the contradiction, and this is the problem which is to be solved. And this is the problem that they feel. Is it objective problem or subjective problem? I do not know. It is a real problem of science. It was a real problem for science many years ago. But today, it is a real problem for the mind of the learning student. he is moving in his education through this problem. So it's subjective. And from the point of view of the teacher or psychologist, the mind problems, the mind processes which take place in child's intellect are objective. So that's what I can say. I hope that I understood the question properly. If it is not so, please add some more explanations of the question. No. Great.
Давай.
Okay. We are answering the question about how do we choose the information and the concepts which are substantial and which are included into the program or are not included. It is not by chance, and it is not one person's choice. Elena told you that we started to make this program about 25 years ago. And the first step was to find the start point. And the start point is just the point Denis Minkin was telling you about. The representing of living being as a black box and the problems which come out of there. Why do we start with respiration, with breathing? Because through this, we can find the way to make students assimilate the concept of energy and energy consumption, energy waste, and respiration as a process that gives energy to the living being, and food as the fuel for respiration, and excretion as a result of using proteins for respiration. And
связывается в понятие организма.
all these processes, the functions, physiological functions of living being, are connected into the concept of organism.
И это первое понятие, которое наиболее близко.
What is an organism? Rather often, biology teachers, biology students, and other people attend it as the word synonymic to the word living being. But it is not like this. For example, if you see a flower or a flowering plant, for example, a rose bush, you can look at it as an artist, thinking about how to paint it. You can look at it as a gardener who will be thinking about the enough water supply for this plant, or how to cut it. You can just feel its beauty and watch it as a poet. But also you can look at it from scientific point of view. And there are different scientific ways. You can look at it as an organism. That means that you think about how it gets mineral salts and water from soil, how it transports the carbohydrates from leaves where they arose during photosynthesis, how it synthesizes the compounds which are the reason of its flavor, and so on. This is an organism, the connection of physiological function, the system of physiological function. You see, when you look at a living being as an organism, you neglect one important thing, important for the other fields of biology. We think of an organism as just of a living being, just living. It does not need to reproduce to live. Reproduction is the thing necessary for the next generation and for existence of biological species, not for existence of concrete living being. So we come to the concept of organism. Then we compare the animal organism with the plant organism, discovering the main thing, photosynthesis. Then we go to the problem of individual development, of reproduction, of heredity. And this is not about the organism, but about a specimen. I'm not sure if I've used the right English word, when we speak about crossing in genetics, we cross two specimens as gen carriers. So we attend the living being as gene carrier, which transfers its genes to the next generation. And it's another way of looking at.
Вот эти все ключевые взгляды.
These key concepts to our mind are much more important to understand the biology, to understand Earth, nature, than the memorizing of a lot of information about systematics and diversity. If thus the choice of the concepts and its succession, their succession, is not by chance. It is the product of very hard thinking of many teachers and psychologists. The big comment, which leader is Елена. Сделай ручкой. Are you satisfied with my answer, or I'll have to add something more? And I also suppose that the audience is tired already.
Да, Троицкий. Юрий Троицкий.
Можете сказать?
Yeah.
Да, скажи.
The question was about the same thing in teaching history.
Не совсем тоже, но очень деятельностный подход.
Not the same, but activity approach is realized in the course made by Yuri Troitsky. I think it is possible to find. So, if there are no more questions, we want to thank cordially all the audience and those honored people who organized this conference and invited us to take part in it. We are very happy to present our new biology course to Brazilian colleagues.
Скажи, что мы надеемся насчет Минки.
We hope that Denise and other participants tomorrow and during the next day,
Наши шведские коллеги.
our Swedish colleagues will be also helpful for you. We hope that it was not very dull to listen to us. We hope that the friendship between Russian and Swedish and Brazilian researchers and teachers will go on. Also, I'm very grateful to our interpreter, Gustav. Thank you so much. We wish you health, good students, happiness, good weather, and peace.
Thank you very much.
Thank you. Goodbye.